So, this is going to be the walkthrough for the dimensional analysis POGIL, and the way we're going to structure it is you should attempt the first several questions in one section, and then come watch the video, and I'll be giving tips on how to work through those types of problems. So try it first before you come back here. So if I'm looking at this particular POGIL, we're going to go up to number 10. And then we'll stop. So work through the first 10 problems, come back, unpause the video, and watch the answers for the first 10, and then we'll go from there. Okay, so you should have finished the first 10 already. If not, go back and do that now. And basically what I'm going to be showing you is going to work through this entire activity. It's going to work anytime in chemistry or even in other science classes when you need to convert one unit to another unit. That's what dimensional analysis is. Okay, changing units. So let's start with question 1. How long does it take to drive 90 miles? So we know that big box, so they have this big box at the beginning with a bunch of values in it, like 90 miles, 75 minutes, and several others, okay? But for now, that's going to be it. The question 1 is about as basic as you could possibly get, and it doesn't need a lot of explanation, but essentially, we can say that because this all occurred on the same model car trip, that all of those values inside the box are equal to each other. Okay, every single thing in there happened on the same trip. It's all equal to one trip. So one trip is the equalizing factor here. Okay, so for number 1, pretty basic answer. How long does it take to drive 90 miles? It takes 75 minutes. Shouldn't take much thinking. Then it says, how long does it take to drive 180 miles? And this is where we're going to start applying our dimensional analysis stuff. So, let's get this all set here. Number 2, here's what I'm going to do. I'm going to introduce some basic fractional multiplication. So, let's do this. 5 times 3 divided by 3. Now, if you're sufficiently far along in math, this should be no problem for you, because if you had trouble, 5 times 3, 15 over 3 would be 5, but you can simplify this by saying that 5 times 3 over 3, well, 3 divided by 3 cancels to 1 over 1, and you just get 5 times 1, which is 5. You could do the same thing with 5 times 18 over 18. Even if you couldn't do 5 times 18 in your head very quickly, you can very quickly say that 18 over 18 cancels, and you always get 5. So the point to take away from this is, anytime you multiply a number by a fraction, as long as the top and bottom of the fraction are the same, you don't change the magnitude of the answer or the amount of the answer. So we'll apply this to here. The question says, how long does it take to drive 180 miles? Even if this is really easy, you can do it in your head. I'm going to show you this strategy will go, because we're going to get a lot more complex problems in the future. So the number, I'm looking at number 2. The number they give us is 180 miles. I'm going to put that out in front. 180 miles. I can multiply that by a fraction, which I'm going to do. And as long as the top and the bottom of the fraction equal each other, I will not change the fact that that was 180 miles, or the magnitude of that answer. I will just change it to a different unit. Now, here are my choices. I know, and if I scroll back up here, that's not a scroll. So let's get rid of that. If I scroll back up here, I know that 90 miles and 75 minutes were equal to each other. Now, obviously, a mile and a minute are not necessarily equal to each other, but I know they both happened and made one trip. So I'm going to say that those things are quote-unquote equal to each other for the purposes of this demonstration. So when I go down here, 180 miles times, and I'm going to multiply by a fraction, I can do it one of 2 ways. I can do 75 minutes over 90 miles, and that should work Because if I multiply by that fraction, I said at the top 75 minutes was equal to 90 miles. And so that should not change how much total value there is. It's like multiplying by 18 over 18. As long as the top and the bottom are equal to each other, my final answer is valid. That's one way to do it. My other way to do it, that will also get me a perfectly acceptable answer, is 180 miles. I'm starting with the number they gave me, multiply by, and instead I'm going to put the 90 miles on top this time. And the 75 minutes on bottom. Okay? And that should also work. Now, while both of those answers do not, because the top and the bottom are equal in both cases, either way I multiply, I get an answer that has not changed its overall value. Okay? However, only one of them gives an answer that answers the question. So if I go back to the question, it says, how long does it take to drive 180 miles? So one of these, when I solve it, will give me an amount of time that it took to drive that many miles. One of them will not give me that same answer, and I'll show you. So when I multiply through here, I'll get my calculator out. If I do 180 times 75 over 90, well, 180 over 90 would cancel, and I would get 2 times 75, which would be 150. Okay, that's one number I get. Now, now let's look at our units. So I had miles on top and miles on bottom. It's just like algebra. Letters on top and bottom can cancel, so I can cancel the miles out. And then I have minutes left. Nothing to cancel with minutes, so my final answer will be 150 minutes. Now let's look at the bottom one. If I do 180 times 90 and I divide by 75, I get 216. Perfectly valid number. But if I look here, I have miles on top and miles on top. Now that doesn't cancel. If I multiply miles by miles, I get miles squared. And I have minutes on bottom, nothing to cancel with them, so I'm going to get miles squared per minute. Both of those answers are mathematically correct, but only one of them answers the question. The question was, how much or how long does it take to drive 180 miles? The one that makes sense is it takes 150 minutes to drive 180 miles. It does not make sense to say it took 216 miles squared per minute. That's not an amount of time. It is a measurement or a value that has units, but it does not represent time. So we can't use that. So this is how we're going to structure our approach. The way that worked, if I go back over here, the way that got me the answer I wanted was the top one, and the top one did this. I took the number, the front number, came straight out of the problem, 180 miles, and when I multiplied, I had to make sure that the top and the bottom number were equal to each other, or equivalent to each other, and I was able to do that because the problem said 75 minutes, 90 miles, all were in one car trip. They were all equal to the same thing. They were all part of the same measurement. Measurement in this case being the car trip. And then the last thing I had to do, or the thing that made it work, was the fact that the miles were on bottom. And that allowed them to cancel with these miles that were on top. So I have to, whatever unit I start with, whatever unit is attached to the number I start with, that unit has to go from there to here. It has to then be on the bottom of the fraction that I multiply by. Okay? So if we're making steps here, your steps would be start with the number from the problem. The number they gave me. They didn't give me more than one number in this problem. It just said how long does it take to drive 180 miles. Okay? That's the only number they gave me was 180 miles, and so I started with that. Next one. Multiply by a fraction. I had to use a fraction to make this work. Sometimes we call this fraction a conversion factor. Let me write that here, conversion factor. And we'll keep going with this. That conversion factor works if top and bottom are equal of the fraction, and the bottom number has the same units of measurement as the original number. In other words, the number out front that you started with. That's dimensional analysis. Start with the number from the problem, multiply by some fraction. The top and the bottom of the fraction have to be equal to each other. We call this conversion factor. And when you're deciding who to put on top and who to put on bottom, the bottom number of the fraction has to have the same units as the number you're starting with. And we saw that up here. Okay? The 180 miles came right out of the problem that they gave me. The fraction was equal to each other. That also came out of the box of data that I had. And the bottom number matched the original number in terms of its units. Then you just multiply. And multiplying by fractions. Okay? So, that's the most I'm going to explain this, and as we go forward, these should go a little faster. So, let's do number 3. How many miles can you drive on 3 gallons of gas? I'm not even going to start looking for stuff right now. I just see 3 gallons of gas. The only number they gave me in that problem. So 3 gallons of gas. I'm going to start with that. 3 gallons. I have to. Okay? That's the number they gave me. That's the number that goes out front. And I know the next step is going to be multiply by a fraction. Okay? 3 gallons of gas times fraction. The fraction is my conversion factor. Now I have to see... Let's see in the problem it says they have 3 gallons of gas. They want me to change that into miles. How many miles can I drive? Okay. So let me go up to the box. If I go up to the box, and you can find this on your dimensional analysis POGIL, the one with the green race car tracker. I see in the box it says 3 gallons of gasoline. I'll write this down here to give it so I know. And it also, where it says miles, I need miles, it says 90 miles. 90 miles. So that's my conversion factor. So let's do this. I'm going to multiply by that conversion factor. And I have to put something on the bottom and something on the top. The something on bottom is where I go first, because it has to match this unit. If I start with gallons, then the bottom number has to be gallons to cancel out. So I'm going to put 3 gallons down here. And I know that's equal to 90 miles up top. Those were the numbers that came out of that one car trip. All of that was for one car trip. Okay? So, now that I have that in place, everything's set, I can just multiply. Multiply through. Now notice that gallons on top and gallons on bottom will cancel. GAL over GAL. 3 over 3 will cancel. And then I'll just have 1 times 90, which is just 90 miles. Again, these problems are not mathematically difficult yet. But if you practice this format, when they do get mathematically difficult, you won't struggle. You'll always be able to get through it. So let's keep going. 4. How many miles can you drive on 1 gallon of gas? So again, in problem 4, they gave me a number. They gave me this, 1 gallon. I'm just going to write it up front. Anytime I see a number that they want converted to some other unit, I'm going to put it up front. And I'm going to multiply it by a fraction. This part should be the easiest part of solving these. Now, the next thing they say, miles. How many miles can I drive on 1 gallon of gas? Now, I'm going to wind up using the same conversion factor as before. But notice that if I start with gallons, I need to get rid of gallons. I'm going to put them right there. I can do this before I even know what the number is, although I do remember it. But I know gallons will have to be the unit on bottom. And they say how many miles? Well, it must mean I have to put miles on top. Okay, how many miles can I drive on 1 gallon of gas? Well, I know up here, 3 gallons is equal to 90 miles. I'm just going to plug those numbers in. 3 next to the gallons, 90 next to the miles. That puts everything in the right place, because now gallons will definitely cancel. And I just have to do 1 times 90 divided by 3. 1 times 90 is 90. 90 divided by 3 should be 30. And the only unit left is miles. So, on 1 gallon of gas, I should be able to drive 30 miles. Good to know. All right. Keep going here. We'll pick up some speed, hopefully. 5. Show how you solved question 4. Be sure to include units in your calculations. Okay, I solved it by starting with the number that they gave me in the problem, putting gallons on bottom and miles on top, and knowing that in the box above they had 3 gallons to 90 miles, so I put the numbers in next to the units, and then I multiplied and canceled, and I got 30 miles. Okay, you saw me solve it. Now we go to 6. Show the miles per gallon as a fraction with numerator and denominator. Miles per gallon. Here it is. Here's miles on top per gallon. Sometimes when you see a fraction, the fraction line itself, you speak it as a per, if you were saying it out loud like a sentence. So miles over gallon or miles per gallon. Cool. Show the miles per gallon as a fraction. So I need numbers now. Well, I know, here they are, there's my numbers, that 90 miles equals 3 gallons. Okay, so if I divide that out, I should get 30 miles per gallon. I don't need to put the 30 over a fraction, I can just do the miles over gallons as the fraction. 30 miles per gallon. That's not bad. If you've got a car that goes 30 miles per gallon, you're actually doing pretty well. You don't pay for gas that often. All right. Who's the numerator, who's the denominator? Miles are the numerator, gallons are the denominator. Okay. Moving along. 7. Using a grammatically correct sentence, describe how you made the choice for number 6. How did I make the choice for number 6? Essentially, I chose to divide them. I chose to make miles per gallon the sentence, or the sentence fragment, I guess, into miles per gallon the mathematical ratio. If I had done it the other way around, I would have had 3 gallons per 90 miles, but that's gallons per mile. That doesn't make much, that doesn't answer the question anyway. 3 gallons per mile is not the ratio they were asking for. So, miles per gallon, usually, whenever you hear someone say something per something, top per bottom, the bottom number is assumed to be 1. So, to answer number 7 grammatically, I would say, I assumed that I had 1 gallon. That was how I did my ratio. And that's always going to be true. If you hear someone say something per something, the bottom, or the second unit, is always assumed to be that's 1 of that unit. Okay, going on to 8. Is there another way to write the fractional relationship of gallons and miles? Show it this way. So let's do that. All right, well, I sort of did that here. 3 gallons per 90 miles, but let's reduce that. 3 gallons per 90 mile is not, because again, if I said gallons per mile, I need to assume that miles are 1, so I need to divide that fraction. So 3 divided by 90 should be some repeating fraction. So 0.033. I'm going to round it. 0.033 gallons per mile is the other way to write this. By the way, those are equivalent. Saying something is 30 miles per gallon or 0.033 gallons per mile is just fine. Okay, it describes the same amount of fuel efficiency for that car. Okay, So that's 8. 9. Why might you want to write the ratio this second way? Okay, well, so let's think about that. This first way, up here, 30 miles per gallon, is really useful if I know how many gallons of gas I have. If I have my car, for instance, my car has a 10-gallon gas tank, very small. If I knew that I get 30 miles per gallon, I can just multiply 30 miles per gallon by 10 gallons and say, hey, I can go 300 miles in a full gas tank. Okay, so that would be useful for knowing how far I could go. But knowing 0.033 gallons per mile is probably more useful if I know how far I have to drive. So let's imagine that I had to drive, 100 miles, and I want to know how many gallons of gas that's going to take. I can just take the gallons per mile, multiply it by 100, and then see if my tank is at least that full before I start the trip. So why would I write the ratio the second way? Let's put the pencil on here. If I need to know how many gallons of gas to use. That would be a very easy calculation for me. Okay, and let's go on to 10. Here are 3 other relationships that we can obtain from the model. And notice all they're doing is writing conversion factors for number 10. Number 10, they wrote 1 bathroom break, which I'm going to abbreviate as BB, per 90 miles. Cool. They wrote 3 gallons every 75 minutes. That's how long it takes me to burn 3 gallons of gas on this trip. And 27 songs. I just wrote 25. How about that? 27 songs for $12. This is apparently how much I spent. Huh. All right. All they're doing is going up to that box, the box with the green eraser in it, and saying these things are equivalent, because everything is equivalent to each other because it all happened on one trip. I took a bathroom break. The whole trip took 90 miles and 75 minutes, 3 gallons of gas, 27 songs played during that time, and $12 was spent during that time. So I could make a whole bunch of other relationships. So let's look up here. I could say that 90 miles is worth $12. I think this POGIL was probably written... No, 3 gallons could be $12. That's about $4 a gallon. Never mind. I could say that 3 gallons is the same as 27 songs. I could say that it's $12 for a bathroom break. All of these things could be equivalent. Okay. And you could write any others that you like. I ran out of space, but they want 4. Any 2 things you can write on top and bottom, and it doesn't matter. So this is another one I could write. I'll go ahead and make it really obvious. I could do $12 is the same as 90 miles. Because I can put them on top or on bottom as I choose. That is totally fine. All right. That should have been the first 10. Now, the next section you're going to go through should take you up to number 16. So you're going to do 11 through 16. Pause the video, do 11 through 16, then come back to the video to see to hear my commentary on it. Okay, so you should have worked all the way up through problem 16. If not, go back and finish that. We're going to start with number 11. Which of the conversion factors from number 10 would you use to determine how long it would take to burn 8 gallons of gas? 8 gallons of gas. So I need a conversion factor. Okay? And so I'm going to write it as a fraction. My conversion factor has to have 2 units in it. They know they're talking about gas, so I'm definitely going to have gallons in there. Gallons is going to be one of my units. And they're also going to need, it says how long would it take, so the other thing has to be minutes. And I'm getting rid of gallons of gas, so I'm going to probably have gallons on bottom and minutes on top. That's going to be my conversion factor, those 2 units, because it says how long takes to burn 8 gallons. Okay, so now I need a fraction, and now I have to go up to that box with that green eraser and find gallons and find minutes. Well, gallons has a 3 next to it. Minutes has a 75 next to it. There it is. So that is the conversion factor I need to solve the question number 11. Okay, let's go on to 12. 12 says, construct the conversion factor needed to determine how many songs you would hear in 500 miles. Okay, songs and miles are going to be the 2 units I need, and it says I'm trying to convert 500 miles, so miles better be on the bottom. Miles will be on bottom, songs will be on top. Well, if I go back up to my box with the eraser in it, it says for one trip it took 90 miles, and it took 27 songs. So I'll put those numbers in right next to the unit they belong next to. 27 songs in 90 minutes. Okay, go on to 13. 13 says, actually solve number 12. Well, I have the conversion factor. Now I'm looking through number 12. I need a number. The number they gave me was 500 miles. That has to be what goes out front. 500 miles. And I know I'm multiplying by the fraction. And I already made my fraction up here. And I know because I started with miles, I have to put miles on bottom. So those are going to be 90 miles on bottom. And then songs have to go on top. That's 27 songs on top. And now I just multiply. Well, I can see some things are going to cancel. Like I can cancel 10 off of that. 27 divided by 9 is 3, so I can cancel that. 3 times 50 is 150. And miles will cancel. Miles will go away. So songs is what's left. So I could listen to, if I went 500 miles in this trip, I would be listening to 150 songs. Which I don't even know if my iPad has 150 songs. Hopefully. Okay, 14. As a group, write grammatically correct English sentences to describe the objective of the activity at this point. Be prepared to share your answer with the class. So, what's the point of all of this? This is about, at the core of it, it's about converting units. But it's also about developing relationships here. So we're trying to find, this problem is a mathematical relationship between how far I'm going on this road trip and how many songs are going to play by in that time frame. So we're relating a distance, miles, to a time frame. In this case, time is measured in songs. All right. So this is. In this problem in particular. This one up here was relating an amount of time I would have been driving to an amount of energy. Gallons of gasoline you could consider a unit of energy. It takes energy to move me across the country. So, but that's a relationship. It's a mathematical relationship, but it's comparing how far I go to how much energy I use. Or how much time, how long it takes me to go a certain distance with how much energy it takes me to go a certain distance. So, anytime you're doing a conversion factor, you are exploring a mathematical relationship between two different quantities. So let's make that a sentence. Conversion factors represent mathematical relationships between different quantities. Okay. All right, so you've shared this. Hopefully we were able to get to this in class, and you've also heard other people talk after having shared yours or looking at mine in this case. Do you still agree with your initial assessment? So when you did this before you watched the video, do you agree with what you wrote down? And if maybe you want to make a change. If you do, write it in. All right? That's on you guys now, up to 16. As a group, can you think of a situation when a scientist or chemist might need to use conversion factors to solve a problem? We're going to do lots. And I'm going to show you how chemists do it. Chemists use conversion factors a lot of times for recipes. So, for instance, we're going to be making solution. Whoop, that was a terrible drawing. Herp. Okay, pretend I have a flask, and I know I want to make inside the flask an acid that I'm going to dissolve in water. And it needs to be a certain strength. People measure acid strength in molar. And I want to make this acid 3 molar. That's a pretty strong acid, because I'm going to be doing some harsh acidic chemistry with it. And so my recipe calls for, let's say it calls for 50 milliliters of water, and I want to make that 3 molar acid, and I need to know how many molecules, because I'm going to have a whole bunch of molecules of acid over here, right, that I'm going to dump into that water to make it a certain strength. If I dump more molecules in, it becomes stronger acid. Well, I'm aiming for this. That's my goal, is 3 molar. So I need enough molecules to go into the flask to make that strength of acid. This is one example, but a lot of what chemistry does, or chemists do, is based on this type of conversion factor. Okay, so I'm going to count up all those molecules and dump them in. What I need is a conversion factor. I need to know how many molecules. Oops, let me actually do that the other way, because otherwise you'll get confused when we get to that chapter. I need to know how many molecules per liter to put in order to get that acid to the right strength. And if I knew, it was, in this case, it's going to be 3 moles, which you'll learn what moles is, per 1 liter would be a 3 molar, and then I know I have 50 milliliters. Now, obviously, those don't match. We would have to change milliliters into liters first. But this is the idea. If I did some kind of multiplication like this, I would be able to make a recipe and say, this is how many molecules I need to get out and dump into that water to make 50 mLs of 3 molar solution. And we will be doing this. So, all right, so we're up to 16 now. The next thing you're going to be doing is all the way down to 23. So, go from 17 to 23, and then come back and watch this section of the video. Okay, so you should now be all the way up and finished with 23. If you're not, go back and finish that first. And it says, solve this problem without using a calculator. So this is just pure math. All right, let's do it. 6, 17 on top. 3, 13 over 13, 9, 17 equals. All right, if you're not good at this type of math, let's get good at this type of math. So, commutative property of multiplication allows you to do these in any order. And so what I'm going to do is I'm going to take that 13 first and divide by that 13, and it's going to go away. Just cancel it right off. I'm going to take that 17, divided by that 17, cancel it right away. I'm going to take that 3, divided by that 9. Now that gives me a 1 on top, it gives me a 3 on bottom. Left over, I have a 6 over here that I can divide by that 3 down here, leaving a 1 down here and a 2 up here. So basically, I got rid of everything except this 2. And 2 times 1 on top divided by 1 on bottom is just going to be 2. All right, this is going to make this really, really, really easy if you can find those types of common denominators and reduce your fractions, because these show up all the time when you're doing conversions. So that was number 17. Number 18 says this. Write a mathematical rule that makes this problem easier to solve. It's the commutative property of multiplication. Ignore my terrible writing. which basically says you can multiply or divide in any order. If you have a group of numbers and they are all being multiplied and or divided, I should say, then what the order doesn't matter. So you take the common factors, cancel them out first. Okay, 19. Solve this problem. So this doesn't give us numbers. It's miles times songs times gallons over miles times gallons. This is also an important thing to know how to do in chemistry because there are going to be a lot of units. When you're doing pure math, you don't always see units because mathematicians are largely just worried about the numbers. And as long as the numbers work out, they're fine. But chemistry, the units matter. In fact, they're one of the most important things. And I would argue in any science, they're some of the most important things you can get comfortable with. Okay? So, and you can treat them just like letters or numbers in algebra. In this case, miles are on top, and if I divide them by miles on bottom, they cancel. Gallons are on top, and if gallons are on bottom also, they cancel. So the only thing left here are songs. So solving this just gives me songs. Okay? Super important. Don't ever downplay that. All right. And they give you the cancellation line. Sometimes people like to write their conversion factors. So in the box they say 6, and they go 17 over 13, and 3 over 9, and 13 over 17. And this can be a way to organize yourself, which is totally okay with a cancellation line. As long as you know that the 17 on top and bottom cancels, the 13 on top and bottom cancels, the 3 and the 9 cancel to 1 over 3, and the 6 and the 3 cancel to 2 over 1. So a cancellation line, if it helps you organize, is perfectly okay. Lots of people use them. Going on. 20. How many miles would you have to drive to hear 43 songs? Show how you solve the problem using units and conversion factors. All right, here it is. Here's 20. 43 songs times. On bottom, I have to have songs. I know that because I started with songs. I have to get to miles. They asked me for miles. So here it is. It's 90 miles in the box and 27 songs. Now, if I want to do this without a calculator, I'm going to have to do some canceling. So both of those top and bottom can be divided by 9. So if I divide the top by 9, I get 10. If I divide the bottom by 9, I get 3. Okay. No more canceling to be done here. 3 doesn't go into 10 evenly. It does not go into 43 evenly either. Songs will cancel. I can do that. So I'll be left with miles, which is good. That's what they asked for. 43 on top times 10 is 430 over 3. 3 goes into 4 one time, remainder 1. 3 goes into 13 4 times, remainder 1. 3 goes into 10 3 times, remainder 1. And you can see that this is going to be a repeating decimal. So I should get an answer of 143.3. That's going to keep going. And miles is the unit that I will wind up with. Okay. So that's number 20. 21. Use that answer, this one, and to find out how many minutes this would take. Okay. Let's do minutes now. So I'm converting miles to minutes. So 143.3 miles times. On bottom I need to have miles because I'm starting with miles, and on top I need to have minutes. That is 90 miles to 75 minutes. And I should be able to reduce this as well. It looks like 5 goes into both, so 5 goes into the top 15 times, 5 goes into the bottom 1, and 4 is 18 times? Oh, I could even go more. It looks like 15 would have gone into both. Okay. So 3 goes into 15 5 times, 3 goes into 18 6 times. So 5 over 6. Okay. So 5 over 6 times 143.3 repeated. Okay, let's try that in my calculator. 143.3 times 5 divided by 6 is 119.4. 119.4. And I don't get miles, I get minutes. So 119.4 minutes. Good stuff. On to 22. 22 says, show how you can combine problems 20 and 22, or 20 and 21 into one big problem. Oh, this is my favorite. Okay, let's go back and look. So I started with 43 seconds and multiplied by this, and whatever I got from there, this answer here, I just went and multiplied by this. You can totally make this one big problem. So 43 seconds. Let's do that first. 43 seconds times, seconds were on bottom. Okay. Miles were on top. But then we took, and they were, let's say that was, sorry, was it songs? Yeah, it was songs. I said seconds. I'm used to S being seconds. So it was 27 songs and 90 miles. Sweet. Then I did this. Times. Miles went to the bottom. And minutes went to the top. And it was 90 miles for 27. Oh, excuse me. I have that wrong. It's 75. 75 minutes. Now you'll notice that if I do it this way in 2 steps, this makes it a lot easier because 90 miles on top, 90 miles on bottom, that's going to cancel right away. And now I'm just doing 43 times 75 divided by 27. 75 over 27 should reduce by 3. So if I divide that by 3, I get 25. I divide that by 3, I get 9. So I'm going to have 43 times 25 over 9. Should be 119. Check in your calculator to make sure. So 43 times 25 divided by 9. Yep, 119.4. Buddy. And notice seconds cancel. Miles cancel. I'm left with minutes again. So I get the exact same thing. So perfect proof that you can all do it in one step and get the same answer. Nice. So let's go on to 23. 23 says, write a grammatically correct English sentence to describe which unit you will be left with in the answer. Let's see what they're asking there. Which unit you should be left with in the answer. You should be left with this last unit that's on the top. So the one you start with will cancel down here. The next one you start with will cancel down here. So it's always the last unit on top. You will, assuming you do these in order, will be left with the last unit on top of the cancellation line. Cancellation line. Good. And that's it. If you follow that, you will be a master or mistress. Does that, no, let's say we're all masters of conversion factors. So the last two, 24 and 25 in this part, are to test that. Now 24 and 25 don't come from the card trip. They're asking you to find your own conversion factors, so you're going to have to either know them or look them up, which is okay. Go ahead and try and solve those, and then come back to this if you're having trouble, and I will explain those too. Okay, so you should have attempted all the problems in the packet. So let's look at 24. Average human heart beats 72 beats per minute. If you live to be 80 years old, how many times does your heart beat? What do you need to know to solve this problem? List the conversion factors. I'm going to write down two things they said. They said 72 beats per 1 minute, and they said 80 years. Okay? Notice that this is a conversion factor and this is a measurement. The conversion factor has 2 units in it, comparing them already. I know they didn't write 1 minute there, but they said 72 beats per minute, and we know from before that if you do per, the bottom one is always assumed to be 1. So if I'm starting with this, I'm going to have to do 80 years as my starting number. And then I'm going to have to convert that into beats. They said, how many times does your heart beat? That's the question. So if I look at that sentence, 80 years is what they give me, beat is the unit they give me, and then beats is the unit they want me to turn it into. So I'm going to have to do something. So let's just kind of go through here. 80 years, I'm going to have to put years on bottom. Now, if I knew how many minutes were in a year, I could just put minutes on top. I don't have that memorized. I guess I could look it up on the internet if I really wanted to. But I don't. So I'm going to do what I do know. I know there's days in a year. I can do that 1 year is 365 days. That I can do. Then I'm going to multiply that. Well, look how days are now on top. So I'm going to put days on bottom to get rid of them. Days. Can I do minutes in a day? I don't know minutes in a day. I do know hours. I do know 1 day is 24 hours. Hours I'm going to have to get rid of next. Hours and minutes? Yeah, I can do that. I happen to have memorized that 1 hour is 60 minutes. Cool. And then, that doesn't answer the question yet. It just gets me close because I know they wanted beats, but they did give me the conversion factor. I don't have to look that up. They just said that there are 72 beats in 1 minute, and that will cancel my minutes. Sorry that got so scrunched at the end. It didn't say to solve this. If you would like to, go right ahead. Notice how everything on the bottom is a 1. This is really easy to put into a calculator. Just 80 times 365 times 24 times 60 times 72. Whatever that comes out to. That's how many times an 80-year-old person's heart beats in their lifetime, assuming that they die immediately on their 80th birthday. But that's, yeah. You get the idea? So, last one, let's do 25. What units should the answer be in? Oh, this is the same one for number 24. Units should be in beats. Just regular old beats. No per. This is because it says how many times did the heart beat. What value would you use to begin the problem? Oh, we already did that. 80. You have to start with 80 because they gave you 80 years. Solve the problem, show your work. Okay, so I do have to solve the problem. All right, let's do it. Put in my calculator here, 80 times 365. If we're being technically correct, it's 365.25. You'll learn that in physics. Times 24 times 60 times 72. And I get... well, where are my commas going to be? This looks like 3,027,456,000 beats if I multiply all that out. Fair warning, if you give me an answer like this in a test, I will mark it wrong out of principle because no scientist is going to record a number that big. They're going to probably round it, and they're going to write something like 3.027 times 10 to the 9th. Notice how many times that decimal is removed. 1, 2, 3, 4, 5, 6, 7, 8, 9. We like scientific notation. It makes small easier to understand numbers, if you get used to it. So, but either way, we'll definitely do a lesson on that later. Beats. We're able to work out using our conversion factor knowledge. All right. Hopefully this was helpful. Hopefully you feel strongly capable of converting because we're going to do a lot of it. I would say there's no section of chemistry that doesn't use conversion factors. It's for everything.